Hi, folks. Hi, everyone. We are here in this Rust Rover live stream series. And the thing is that last week we got a huge announcement. We actually made Rust Rover commercially available for everyone. And one more thing is that it's free for non-commercial use. So if you want to use Rust Rover for hobby projects or maybe for learning Rust, then you can do it absolutely for free. It's the same Rust Rover available for everyone. But I'm here not to talk about Rust Rover because I have an amazing guest. I have Will Crichton here. Hi, Will.
Hi, Vitaly.
Uh, so, yeah, I'm interested in what Will is doing because he's working in the area of how to teach Rust. And this is extremely interesting for me because I myself spent more than 20 years teaching various programming languages. So it's a very nice topic. But of course, Will did a lot of other stuff as well. So please, maybe you could start with a brief introduction on what you are doing, what you're up to, and then we'll start from there. And
Okay.
I will bring your screen here.
All
So
right.
the stage is yours.
Thanks. Yep. Hi, everyone. My name is Will. So just a brief history. So I finished my PhD at Stanford in 2022. I'm finishing up a postdoc right now at Brown University. And starting in 2025, I'm going to be an assistant professor of computer science also at Brown. So I'm full-blown academic. And broadly speaking, I research the human factors of programming languages. And just to give you a quick sense of my kind of animating principles, let's see. So, I really believe that beliefs about human behavior drive the development of programming tools. And you can really see this in the history of programming languages. So, for example, if you look at like the invention of compilers, you can see someone like Grace Hopper saying, "Oh, compilers were created because people wanted to solve problems, but they didn't want to learn like this in the 1950s. This was octal code and manipulate bits at the lower level, so they invented higher level abstractions." Or Dijkstra invented structured programming or argued against GoTos because specifically making a cognitive argument that our intellectual powers are geared to master static relations. And Tony Hoare, another famous programming language designer, said that the primary purpose of a programming language is to help the programmer in the practice of their art. And I find all these interesting because they show how when the most important people in computer science were developing some of the most important ideas in computer science, they had a fundamentally human-centered lens. They saw their own ideas in a sort of human-centered way, but there's never really been a science of how to approach the human factors of programming. And I think you can really see some of the effects of that today, how if you look out into the programming language ecosystem, you see every language is reporting serious issues with learnability and usability. So here's just some survey data I found from the most recent iterations in various ecosystems. Like in Go, I think that the number 2 highest reported challenge was the learning curve of the language. Even Go, which is supposed to be a very learnable language, in Scala, there were tons of respondents who wanted to see better educational materials for Scala. If you ask people in OCaml, think the tooling is very confusing to newcomers, and they strongly want to see more courses for students. You can find similar things. Clojure programmers want to see better error messages. They want to see better tutorials. And so this is a really interesting state of affairs, right? I think we all kind of agree these tools should be more learnable and usable, and then that's essential to the impact of these tools. Good ideas don't just exist in the ether, and no matter how great the idea is, if nobody can work with it, it won't have an impact. But there's not really, how do you systematically improve and any of these aspects. There's no science to it. And so that's really the question that I'm interested in, is something like, how can you use psychological theories and methods to systematically improve how people learn and use programming tools? So at a very high level, I think that's ultimately what my research is about, or at least the main focus of a lot of my research. So I'll give you just a quick overview of some of the papers that I've written, and to give you a flavor of what this looks like. So, for instance, in one paper I looked at, I was curious in how people would read through programs. And in particular, if you ask people to run a program kind of in their head, how the state of the program as it gets bigger makes it harder and harder for you to remember all the like values of the variables. So, these graphs basically show someone's attention over time for a given program. So the program is over there on the y-axis and time is on the x-axis, and you can see someone jumping from different lines. And through these kinds of graphs, you can compute things like, how often do we think did people forget a piece of data because they had to go back and revisit it again? And we can try to build sort of a theory that predicts, oh, given this program, we expect that people on average will remember this much information or forget this much information. That was the idea in this paper. In a later paper, so that was a sort of more, let's understand programmers as they are and give them programs. This project was more on building developer tools. So I created this tool called a program slicer. So as you can see it here, if you click on a variable like this mutations variable, the top is selected, the parameter to the function, then it will filter out all the code that cannot be affected by that variable. So in this case, only those 3 lines of code are affected by mutations. And this is a comprehension tool, because as you're reading through code, you could be clicking on things and getting live updates to just quickly get, especially in a big complex function, you could say, oh, these branches have nothing to do with it. This set of code is irrelevant. And so this is a tool I wanted to build. But you've probably never seen something like this in an IDE before, because it turns out this is a relatively challenging program analysis problem to say, how do you answer the question of, could this line of code be affected by this variable? That's somewhat tricky. So that's what this particular paper is about, is we answer that question. Could this line of code be affected by this variable, specifically in the context of Rust? So we use some clever aspects of the Rust type system in order to make that problem more feasible, essentially. And then, so that was my dissertation work, along with some other papers I didn't mention. But in the postdoc this past 2 years, I've been getting a lot more into Rust education. So we've been doing this big experiment on how do people learn Rust, and how can we better teach people about Rust? And that's, of course, primarily what this stream is about. So this paper, A Grounded Conceptual Model for Ownership Types in Rust, is basically about why is ownership hard for people to learn? And then what are kind of ways of understanding ownership that we could teach people that we think are more effective at helping people, especially when you get a complicated ownership error, helping people understand how to debug those kinds of errors. That was really the main focus in this project. So this particular diagram, which I can go into more detail later, is the way that we want people to think about ownership is in terms of these permissions. That's what these RWO letters are. And we can visualize how these permissions change throughout the course of a program as you do things like create references to data, and those references become no longer live, and that affects the sort of permission state of the program. And these diagrams are also automatically generated, pulled directly out of the Rust compiler. That's an important aspect here, is anybody can generate your own diagram. I can show you the online REPL later. And then the last thing I'll note is I'm increasingly interested in communication technologies. So what are the tools we use to talk to each other, or create diagrams or texts? So I have an ongoing project to create a new document language, something like a successor to LaTeX or Markdown. It's called Noda, and there's actually a live version if you want to play around with it. It's undergoing a lot of iteration right now, but and we're also doing academic work on this. Like, we have a paper called a core calculus for documents at a PL theory conference that's sort of about the more formal aspects of what is a document language really? What does it mean to do templating, formally speaking? And how would you model that using something like the lambda calculus or one of the many tools that you would use in a PL theoretician's toolkit? So, anyways, a bunch of different projects just to give you a flavor of what I do. But again, the core principle is, how do you take a human-centered lens to the design of programming languages? And one side of that, which I mostly emphasized, is the kind of the rigor, the science. How do you use psychological theories and methods to do better work in this space? But also, I think like as the document language thing is a good example of just, I think there's a lot of problems that people ignore, especially in academia, especially in programming languages, because they are thinking, oh, I'm only going to work on super general purpose languages. I'm only going to work on the fanciest type theories, right? When in fact, there's so many interesting design problems everywhere you look, and even in something like document languages, I think is a totally underserved topic. But I have to write documents all day, and I would love to have a better language, so that's something I like to work on. So yeah, that is a quick overview of my research.
Yeah, nice. Thank you very much. Well, let me start with this maybe a little bit harsh question.
Please.
Do you think that learnability problems are issues for programming language design? So if there are learnability problems, does it mean that it's a problem for a programming language? So we might like design language better to avoid that stuff.
Yeah. It's a good question. So I think the answer is yes and no. Um, it's true actually. If you read a lot of literature on programming language education, especially like when it looks at languages like Java. Well, actually, let me start over. So a lot of educational research often comes from domains like physics, where we say there is one correct model of physics, and my goal is to teach it to you. And if you don't understand the correct model of physics, Newtonian mechanics or whatever, you have a misconception, you're wrong, and we have to correct it, right? Whereas, of course, and then what happens is then researchers import that same model into looking at a language like Java. And they'll look at some insane part of Java. They'll be like, oh, students don't understand that only objects have default values, but primitive types don't have default values. That's a misconception, and clearly we must correct it. When instead you might be going, well, maybe that's just a bad idea, right? Maybe we should just not, we should have a language that doesn't do that and correct that. So I think that's totally correct that there is a fine line to walk, uh, because when we say people are having trouble learning this, that can also be a sign that the language itself should be improved. But that said, I think there's two reasons also to just focus on the learnability problem. One is artifacts are designed the way they are. All artifacts have problems, that is true, but at the end of the day, you have the artifact or the language you have, and you need to learn it one way or the other. But the second, I think, is that the more the sort of the deeper argument is that ideas are complicated, right? And it is in the same way it's hard to learn, quantum mechanics or something. It is also hard to learn very sophisticated type systems, for example. They're just not simple. They will take time to understand, and that complexity is worth it, right? That complexity reflects decades of investment into the creation of systems that enable us to describe software and reason about its correctness at a high level. And so I believe that it's worth like tackling as is, and I think this ownership project really is a good instance of that. We say we think ownership types as they exist in Rust are a good idea. Um, there are small things you could change about them, but like for me, the big issue was just that ownership types were being presented in a very opaque way. I think the way that most Rust texts treat ownership types. And when I say ownership types, I'm basically referring to the system of ownership. So this is moving things and the notion of uniqueness and linearity, as well as references, shared and immutable, or immutable and mutable ones, and as well as lifetimes and named lifetimes. All that's kind of ownership. And The problem is most texts would just sort of present you this bag of heuristics for understanding ownership types. So they would say, if you have a program that looks like this, you have two mutable borrows on the same data, that's an error. Don't do that, right? And they wouldn't really give you a first principles way of reasoning from what should I expect this program to violate the ownership type system? And that's really more what we try to do here. Because, for instance, one cool thing that this system can do that's not obvious just looking at, say, this example is a well-typed program. Like, you can run it through the Rust compiler and it will work, but you still can see what the ownership system thinks about your program. Whereas normally you can only learn about ownership through errors, right? You write a bug, the compiler spits out a complaint, and through that complaint you learn something like, oh right, I borrowed this thing here and then I used it there, and that's not good, right? But I think giving people a sort of a more first principles constructive way of thinking about this, and one symptom of that is, say, oh, I can reason about it even on programs that are well typed. That's the hallmark of, oh, I kind of understand the system on a deeper level. And we have some nice data to back up that we think this is a worthwhile idea, that teaching people these concepts at a deeper level helps them in practice understand, work with realistic type errors.
Well, while we're here, so I see this visualization, and it's not immediately clear to me. What does it mean actually to
Yes.
have those, like? Well, I assume it's like reading, writing.
Yep.
So like we programmers, we usually work with text, right? We write code as
Hmm.
text, and we read text all the time. So you say that adding this one more aspect to the code makes it easier to reason about what we have there. But I think it makes sense to go deeper at this time. But before you're doing that, could you please explain this diagram? So what does it mean? How are we supposed to read it?
Yeah. So one thing I'll just note here is, if you actually want to see, like, so if you go to rust-book.cs.brown.edu, this is our fork of the Rust programming language where we've been doing our research. You can also find this linked from the main Rust book at doc.rustlang.org/book. And in particular, if you go to chapter 4 on understanding ownership and the subsection references and borrowing, we have an extended explanation of what this diagram means. So that's in part a tacit answer to your question. We don't expect people to just look at this diagram and immediately gain insight from it or to understand what it means. It does take some training to understand this particular notation, but we think it's sort of worth it, that once you've understand what this diagram means, which we go through by explaining all the specific pieces, then we slowly build up an understanding, and so on. And so I can actually just show you in the context of the book. Maybe it's a little larger and take out this. So the basic idea of what this diagram is, so this program has a vector. So this vector v with the elements 1, 2, 3. We create a reference to an element of a vector. That's this num. We use that reference by printing it out, and then we mutate the vector at the end. This is a well-typed program. And what these permissions are showing is, when I create this vector v, the permissions show what I'm allowed to do with the vector while it's in use. So here, read is like, I can get the length of the vector. Write is that I could say, add an element to the vector. And own is like, I could move this vector or I could drop this vector. I can act as an owner of the vector. And the most interesting bit here are these next two lines. So when you create a reference to an element of the vector, so when num is created, then a couple things happen. So first, v loses some of its permissions. So you cannot write or own the vector while num is in use. And then these two paths, so star num is the data access through the reference, and you can read that because it's an immutable reference. And then the reference itself has read and own permissions. And then once you have So here we create the reference and then we use it here, and then it's no longer live. So if you're familiar with the phrase non-lexical lifetimes, this is showing an instance of non-lexical lifetimes. So once num is no longer used, then v can regain its permissions. So you're now allowed to write and own the vector because there are no pointers into v except for v itself. And then you can't use num or star num anymore. And that allows us to push to v on this line. And so let's see, do I have the example where this breaks? Right. And the key thing then is this helps you understand why programs will be rejected by the borrow checker. So if we swap the order of the last two lines, so now that the push happens between the print and the creation of num, then we get the initial vector v with the read, write, and own. The same change in permissions happens when we create the reference, but now you can see that the letters over here on the left indicate permissions that are needed in order to do something. So in order to push into V, we need the read and the write permission, but we only have the read permission and we do not have the write permission. And that's also roughly what the Rust compiler would say. It won't use the term permission, but it'll use something similar. And this is kind of our way of explaining how the borrow checker thinks about your code. Like another way to think about it is from the borrow checker's perspective, it doesn't understand what push means. It doesn't know that push means add an element to a vector. All it knows is that push means I'm writing to V. And that's all it needs to know. This read, write, own is an abstraction, right? It's a kind of, you squint and you produce a summary of what a method is doing, and that's all the borrow checker reasons about, is essentially these summaries of the behavior of operations.
So I see that well, there was definitely hard work designing these diagrams, and well, because they look nice, I should
Thank you.
confess. But do you think that it is important for like visualizations for learning to be nice in order to make it easier to learn? Like, is it part of the game here?
Mm-hmm. Yeah, so I think that there is functional visual design and aesthetic visual design. Both are valuable. The functional design is especially important. And I think actually a really good example of this is we can compare this versus RustViz. So RustViz is another tool produced by University of Michigan. And they have, let's see if I can bring up their example here. Sorry, it's a little small, but hopefully you can kind of see. So
Yeah, I think we can see
yeah.
it. Yeah.
So when this work predates ours, and when the folks at Michigan said we want to visualize lifetimes, they came up with a very different kind of visual notation. So you can see in their visual notation, roughly speaking, you have this what looks more like a timeline. So you have these tracks for each path. So S, R1, R2, R3, and then the ownership of S is indicated by the sort of contiguity of this blue line. So the string S is readable here, except the point where you create like a mutable borrow of it, and then you go over here. And then once that mutable borrow is done, you come back, and then it's available. And there's all this extra stuff. You have the little ticked lines, and you have these Fs and stuff. And this is another way you can visualize ownership. And there's a really interesting question, right? Which one of these diagrams is better? Is there a better one, right? And other people also have proposed other visualizations of ownership. You can find them out on the internet. And it's hard to answer better, of course, because they emphasize different things. So for example, what this diagram on the right, the RustViz emphasizes, is the notion of live ranges of code. So this diagram makes it, and one way to, when we think about emphasis, the way to think about it is, what does the diagram make it easy to see, right? And so what this diagram makes it easy to see is when I'm looking at a given variable, I understand when that I can use that variable. So I can very easily see in this range of S, I know that I can use S on every line except like lines 8 to 9. That's a simple inference that you could make, because thinking a little bit mechanistically, right, the inference I'm making is find all the gaps in this horizontal line, and that's very easy for me to do perceptually. Uh, and then and if you say, well, also on a given line, what can I do with this variable? Then I think that's not too difficult here, because in this case, it's based on, is the pipe solid or hollow, I believe. Um, and then you could also say on a given line, why did the permissions change? Or why was there a change in the behavior? That's a little bit less obvious. You just have these big gray bars that don't really explain themselves, right? Um, and but actually, I think the biggest issue with this notation. So I think that's worth observing, and in particular, then the contra thing to observe is our diagram is not good at showing lifetimes. I think that's the biggest drawback to this visual representation, which is let me just go up the example. The fact that num lives from this line to this line is only implicit in the fact that num is created here and sort of deleted here. So that information is present in the diagram. You can see it if you look hard enough, but it's not immediately obvious. That's an example of something that takes sort of more mental cycles. And the reason, but I think in this case, actually, the biggest trade-off is that this diagram on the right is very non-scalable. It is difficult for it to describe more complex programs and still have a visual notation that works in all of those cases. Because, for example, a very important thing for us is we can describe multiple transformations of data on the same line. So here, when you do this num thing, right, then it's with any number of variables. You could have 100 or 1,000 variables in this program, but if you only change 2 of them or 3 of them, only those are going to show up here. Whereas here, if you have 1,000 variables, your canvas stretches off to infinity because you need a track in the timeline for every one of those variables. And that doesn't matter, of course, for these simple examples, but when you have more complicated examples, like you have a data structure with a bunch of fields or something like that, that level of conciseness, that brevity becomes more important. Um, and additionally, right, I would say what our diagram makes obvious, or the thing that we are visually emphasizing in our diagram is the permissions, which is what can you do with something and what can't you do with something, and what is the effect of a given operation on those permissions. Because from pedagogically speaking, right, that's what we think is the most valuable thing for someone to understand. And I can talk about the research behind that. We have some reasons to believe that that's the case. But that was kind of like the design goal was the main thing we think people don't understand about ownership is what are the restrictions being imposed by the type system, as opposed to liveness. Like if you read, for instance, the rest of his paper, they have a statement which is something like, we think the hardest part of ownership is liveness. It's that people don't understand the live ranges of variables, and that's the main thing we want to visualize. And I just disagree with that statement. I don't think that's the hardest part about ownership. I think the hardest part about ownership is permissions and the understanding of sort of the flow sensitive capabilities of variables. And hence that's more what we designed our diagram around. But that said,
But
yeah, go ahead.
by the way, do we have a way to evaluate which approach is better, which explanation is better? Something that can be done not by beliefs, but
Yes.
something more objective?
Yeah. So it depends on what level of evaluation. So in the context of a diagram design like this, I think there's two levels of evaluation. One would be a micro task. So a micro task, and I've not done this, so this is more speculative. A micro task would be I give you a single diagram and I ask you to make a simple inference about it. So I say something like, "Can I write to num on line 3?" or something. And you would look at the diagram and you would sort of read through and say, "Oh, but I see that it has the right permission or it doesn't or something." And so, but no, I can't write to it. And then similarly, I could ask the same thing about RustViz. Can I write to S on line 6? And that one's actually a little bit less obvious because you actually can't write to S at the beginning of line 6, but it still has a solid bar. So you'd have to do some reasoning about it. And you could ask people lots of these questions. You can come up with a dozen different kinds of questions and say, and then give people those questions with each diagram, and then measure how long does it take them to answer the questions and how accurate are their answers. So that would be the kind of classic approach to evaluating a diagram as is. And that's very similar to how people study data visualizations. So if you say, here's a pie chart and here's a bar chart. And then if I ask you questions like, is this number bigger than this number? It's easier to usually to do that between two bars than two pie slices if the numbers are close together. And no one's done that research, neither us nor the RustViz folks, but I think that's like an interesting question. Now, the question we have asked, which I can talk about more, is the macro question. So that says, when we give people these diagrams, does it make a difference in their long-term understanding of Rust? And so the way that we did that in the Rustbook experiment, or a major part of the Rustbook experiment, is incorporating that kind of learning-based evaluation or learning outcome evaluation into the experiment. So how we did it is we came up with these ownership questions. And I'll show you an example. So in an ownership question like this, we say, if you tried to compile this function, which of the following best describes the compiler error you would get? So this function make separator takes as input a string, a reference to a string answer. It returns an answer. And then it says, if the string is empty, then create default. Default is a capital S string and return a reference to that. Otherwise, return user str. So, Vitaly, would you like to guess?
No.
No? All right. So the issue here, right, is that this is returning a reference to something on the stack. So it is, in this case, you would get cannot return reference to local variable default. The second question we ask you about the same program then is, this one's a little more subtle. If you try to compile this function, the compiler returns the following error, blah, 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 blah. Now, assume the compiler did not reject this function. Which, if any of the following programs, would pass the compiler and possibly cause undefined behavior if executed? And in this case, the one we're going with is this one, that you have to call S and then use it. And then we give a final question. Of the following fixes, which fix best satisfies the criteria of it passes the compiler, it preserves the intention of the original code, and it introduces the fewest unnecessary inefficiencies? And so there's a couple options here. So this one is not well typed. That's a bad idea. These two are both valid. And in this case, we prefer this one, I think. But honestly, this one a little bit comes down to taste. But we think this one is a probably better captures the intention of the original author of the interface. And so those are the kinds of questions we ask. And actually, these programs were not picked arbitrarily. We went to Stack Overflow and we looked at all of the top voted questions about ownership. And these programs represent essentially those snippets in a sort of simplified and pedagogic form. And the key thing here is we picked those three questions very carefully to represent the different stages of reasoning about ownership. Like, what is the compiler's view on this? What is the runtime's view on this? And what's the developer's view on this? Like, why is this ill-typed? What is actually the problem? And what's the best way to fix this? And so we think that this kind of question is a good way to evaluate, or at least it's the best way anyone's come up with to evaluate someone's understanding of ownership in Rust. And
so is it about evaluating knowledge, or trying to evaluate educational material which was used to acquire that knowledge?
Right. Well, good,
or
good, good, good
both?
point. So both. So the test itself is evaluating your knowledge, and the test embedded in the book is also evaluating the book's ability to give you that knowledge. So the experiment that we ran is we put this specific test into our version of the book before we added the diagrams. So this was people reading what's basically the current Rust book, and then answering these quiz questions. We get some baseline scores, and then we added the diagrams in, and we could do basically an A/B test. So after we added the
What's
diagram, mhm.
what's the timeline here? So how
So in this
much
case,
time was spent at first stage and then?
it was about 6 weeks in both conditions. So this was enough time for about I think like 300 people total, roughly 150 in each condition, to complete the test in both cases. So we had some in one, some in the other, and the main finding that we had was that when we deployed our diagrams, the total scores. Right, I can just bring up the paper a little bit. If you're curious to see the raw data or raw-ish data. Uh, yeah. So basically, what we found. So this table summarizes what we found is across a bunch of the different questions on just over half of them, there was a statistically significant increase in the performance or in the accuracy of readers on the question after we deployed the diagrams. Um, so specifically here, the way to read this table is like on this question, or sorry, on this task. So make separator is the one we just looked at, and question 2 is the one where I ask which of these programs causes undefined behavior. Before, 33% of readers got it correct with a sample size of 1,120. After, 40% of them got it correct with a sample size of 660. That is an increase of 7%. This D is a statistical thing called Cohen's D. This is a way to, you would call it, normalize the effect size, which is basically saying it's how big is this number relative to the size of the sample. So the bigger the sample, then we can sort of have more confidence about what this D is, as well as relative to sort of these before and afters. And then this p-value is how confident we are that this is just distinguishable from noise. So is this just random variation in the data, or is this likely a real true difference in the population averages between the before and after? And so we find that, overall, there's about a 10% or like a 1-letter grade difference between people's performance on these questions before with the base book and with the diagram enhanced book, essentially. And so and just to emphasize, you can't really conclude that the diagrams specifically caused this, because the actual intervention was an entirely new chapter. What we're really saying is it's a broader pedagogy that caused this. So when we came in and replaced the whole chapter and put it in with this new content and quizzes and everything else, the sum of all of those parts is what caused this change in learning outcomes. That's why it's a sort of macro level evaluation.
As a book author, I think so. Is it feasible to apply this method of improving book or educational materials content to other materials as well, or it's like a gem and something which is not repeatable because maybe it's very complicated to do things like that?
Mm. Yeah, great question. Glad you asked. So the short answer is yes, it's very feasible and relatively easy to do this for other content. So this paper was just focusing on ownership, but we have a follow-on paper that's talking about using quizzes to understand sort of the entire Rust book. Because so one thing I didn't emphasize. Let's go back to the Rust book. So if you go to any one of these chapters, so if I just click on hash maps, and then I scroll down, somewhere in the chapter, there will be a quiz. So this is one of the big changes we made besides the diagrams, is we added these embedded quizzes everywhere inside of the book. So you click this and you can answer some question about the semantics of hash maps or something like that. And we collect all of this data. So a key element of the experiment, whenever somebody answers a quiz, we take their answer and store it in a database. And now we have this big stream of data of people answering all these questions. And so
I'm
here,
sorry, just
yes.
well,
Mhm.
with this question, sorry for asking this, but
Please,
I
please.
know for sure that many learners are actually unhappy about this sort of questions, because they say, well, if I have some compiler error in my code, then my editor or IDE will definitely tell me that.
Yes.
So it's not. It's like writing code on a whiteboard. It's
Yes.
meaningless because I will always just I have easier way to figure out is it correct or not. So
Yeah.
what would you answer to them?
Yeah. It's a totally valid point. There are many kinds of questions, some of which you could trivially answer by pasting the code into the Rust compiler. And our basic argument is the it is generally speaking true. Like, you can find evidence for this in computing education literature, that the ability to mentally simulate a program, even on pencil and paper, just the ability to simulate a program is a building block of understanding a programming language. That if I can step through this program and tell you what each of these lines does without assistance from the compiler, that means I understand something about the semantics of Rust. Obviously, I can just run it and get something from the computer, but this is testing my understanding and not Rust's understanding of itself. And the kind of the key leap, right, is this is a concrete program. I can actually run it. But once there are elements of this that make it harder to run, like one of these is a parameter to the function, and I don't have a particular value for that parameter, then now I'm still engaging in the same process of going through and saying, well, if I did this, then this would happen, and this would happen, and this would happen. You're doing the same process in your head, but now it's slightly more abstract. You're dealing in a domain of variables that don't actually have real values, but instead might just have generic types with certain constraints on them. And that's kind of the argument for why tracing, so that's the name for this task, is a tracing task. Tell me the value of this program. Tracing is valuable. Now, that said, let me get to your question. Let me put this question on the back burner, because one thing we looked at in this study is what kinds of questions were better and worse at predicting people's overall test performance. And I think you'll find those results interesting. So, okay, right. Just to return to this, the thing I was saying is we added these quizzes in every part of the book. We collect people's data of what questions they get right and wrong, and that gives us a view on the book that looks like this. So this is a dashboard that I built to help understand the data for myself. And what I can do as the person running the experiment is I can go through and say, what are the hardest questions in the book? Actually, I'll show you what are the easiest questions in the book. This one doesn't have a hole. Oh no, this one's pretty good. So, like, the easiest question in the entire Rust book is, if I assign X to a null pointer, will that compile? And everyone says, no, that will not compile. Everyone knows there's no null pointers in Rust. So that's awesome. All right. And then let's do a harder one. So this is an example of one of the hardest questions in the Rust book, which is, which of the following are situations where using unsafe code is an idiomatic method for working around the borrow checker? And this one's in particular hard because there are like 4 options and you have to pick the subset of them that are correct. So there's a combinatorial space of answers. And basically, people generally speaking often get, 1 or 2 of the correct answers, but not all 3. And so that's what makes this hard. And so this is cool. I think this was really interesting to see this data, because just seeing this data alone helps you understand 2 things. What concepts in the language are people struggling with, as well as, or sort of related to, what is the book doing poorly at? What is the book trying to teach you, but it's not doing a good job at teaching you? Now, of course, this all depends on which questions you ask, but assuming that you've written some interesting questions, then they can help you measure comprehension of the book. And so one thing that we did separately from the ownership stuff is we took a dozen of these questions and we said, all right, let's take a dozen of the low performing questions and just look at the answers, right? Look at what are people saying, like what are the wrong answers that we're getting, and what do those wrong answers tell us about people's mental models, where we think they're going wrong, and then we go back and change the book. So we make and I have a good example. This is all
So
described.
this is interesting. You mean so you can discover those areas, weak areas, and then you can also improve the situation with them.
Yes, exactly.
Yeah, great.
So this is all described in another paper called Profiling Programming Language Learning. And actually, this is probably a good
I
example of
like.
an
Sorry. I like this like profiling.
yeah,
It's important stuff in software development, and it looks like you can do the same thing with learning itself. That's
yeah,
nice.
exactly. Um, and so just to give you a quick example of what this looks like. So one of the questions we looked at in this paper was there's a question about strings, and in particular, the in-memory representation of a reference to a string and capital S string versus a string slice and lowercase str. And the question we were asking is, which in-memory representation is larger? The answer is the and str because of the way that this is a sort of fat pointer that has the length embedded into the str, whereas of course the capital S string is just a pointer to a piece of data. And the major so people were performing poorly on this question. And we went back and looked at the string chapter and said, okay, why do we think people are not getting this question? Now, one easy thing to look at is the question confusing? For instance, are people not understanding that we're asking just about the size of S2 and not the transitive closure of all the things that it points to? So we made very sure to include the sentence like, not including the size of pointed data, for example. Then we went back and looked at the book.
So
And
it's like here you try, like as usual when you learn some programming language, you start blaming compiler and not something that you wrote. So
yeah,
here you assume at first that it's the question that is a problem, and then you try to realize that it's not the problem, so you fix it. Okay,
right. Or at
that's
least
fair.
it's more like you don't want to just always blame the learner. It might not be their fault, right? But in this case, what we hypothesized is this diagram on the left is the one you find in the main Rust book that they use to explain how strings work. And so they have one owned string S and then one string slice world. But we noticed that they didn't have an illustrated example of a capital S and string reference, which we think would be well, obviously it's valuable in this question and would be valuable to help demonstrate the difference between a reference to an owned string and a string slice. And so all we did is we updated the example to have both. So in this case, the new example has an owned string S, it has a pointer to that S, and then it has two examples of slices. So this is the second diagram on the right. And what we found is after deploying this new diagram, performance went up by 20% on this particular question. So specifically, I have the table here. This was string slice diagram. So before, people got that question correct 23% of the time, and after they got the question correct 43% of the time. And that's cool. That's exciting. And so we did this like 12 times. That's actually what this whole table is. And it didn't always work, but for the times that it did work, on average, we had about a 20% improvement on a given question. And so I think this is the kind of workflow we would advocate other people can do that is not too involved. Because essentially the workflow here is come up with a question, put it in your book. I'll just briefly plug here. So if you are using MDBook, which is the technology used by the Rust book, we created an open source quiz plugin that we use called MDBook-quiz. And you can just grab it and pull it in. You can use it for the exact same types of questions if you want. I don't know why GitHub isn't loading, but you can go to this URL later. All right, come back to that. So you make a quiz, you stick it in your book, you gather the data. In our case, we just literally like stream the data into a SQLite database with a simple Rust service. And then you go back and analyze the data later. You create something like that dashboard. You perform an A/B test. So you look at the data, you generate a hypothesis for why it was wrong, try making a change to the book, wait long enough to gather your post data, see if it helped. In some sense,
So
it is that simple.
this approach can definitely work for any programming language. So nothing special in Rust here.
Oh, and it could work.
So just
This isn't even specific to computer science, of course. In some sense, this is just like part of this project for us was just like people just have this is simple, like sort of MOOC online education stuff that just nobody has tried in the CS context. And for us, I think the sort of computer science specific question and the programming language specific question was, what can you learn about programming languages specifically through this this kind of experiment? So that actually gets back to your earlier point. Let me bring that up. Where do I want to bring this up? Yeah, perfect. So one of the questions we asked is, can we use this data not to understand the learners, but to understand the questions? So, because someone might want to look at this data and say, let's say I'm making a Rust exam, which of these questions would be best to put on the exam? And there's actually a whole field called psychometrics, a field of research that looks at the systematic construction of tests, or instruments, as they like to call it in that field. You construct instruments that measure some aspect of a person's abilities. So that there's a lot of cool research there, and one basic idea there is this concept of item response theory and measuring. So in particular, the metric that we initially computed, the basic idea is the quality of a question from one angle is, how does this question correlate with overall test scores? So the idea there being, if correctly answering this question means you are very likely to get an A on the test, and not correctly answering it means you're likely to get an F on the test, right? Then that means that question is like sort of a hinge point. It's answering something, it's getting at something really important, that is highly predictive of your overall performance. Or if it's not doing that, then probably that thing is measuring something that's totally irrelevant to your Rust knowledge. And so one thing that we found is there are many, like in general, the sort of more interesting kinds of questions have higher correlations. So, for example, the questions that ask you about like the ownership exam I showed you, those types of questions, generally speaking, are high correlation, because they are measuring some kind of like deep understanding of Rust. But interestingly, we very consistently, questions that ask you about programs, where the correct answer is there's a type error, all of those questions had, or most of them had, a very low correlation with overall Rust performance. And in particular, because many of them had the flavor, I think, of a gotcha. It was like, oh, you thought this program was going to compile, but it doesn't actually. So like in this case, it's because you can't move out of a vector like this. You would have to put this behind a mutable reference or something like that.
Well, I would say some professors definitely need those questions in their exams, especially if their goal is to give F and not A. So
That's
that
right.
may be the case.
If your goal is to decorrelate performance in your exam with true understanding, then that's a great reason to add these questions. And so, yeah, but I think that this is interesting, and what's cool about this is this might, subject to more validation, point at a more general phenomenon, right? Is that if one thing we want to do is look at this in other domains. Say, if we put this in a Java book, an OCaml book, whatever, are the same findings true? And if so, this is like building a theory of computing education. It's saying these are kinds of questions you should be asking or shouldn't be asking if your goal is to measure someone's competency in a language. And one other fun thing I'll mention is we did a cute little experiment here. This is this figure 8, where we asked, what is the subset of questions with the highest correlation with overall performance? So if you took someone's average on a given set of like 3 questions, what is the highest correlation you can find at subsets of size 1, 2, 3, 4, 5, and 6? And so, for instance, if you just have one question, you can't get better than like a 0.4 correlation. But if you get up to 5 questions, you can get a 90% correlation, or R equals 0.9, I should say, between the questions, between those 5 questions and overall performance.
So
And so
does it really mean that you don't need those long, many hours exams with hundreds of questions?
it
Isn't it
doesn't.
a revolution?
Right. The way to think about it is it absolutely does not mean that, because all of those other questions, again, because the questions serve 2 purposes. They serve one purpose as first, well, actually, they serve several purposes, right? In the Rust book, the questions serve the purpose of, does someone understand the specific concept being tested by the question? And as well as they serve the learner the purpose of forcing them to review that concept and thereby strengthening the neural connections in their brain. And, this is the sort of spaced repetition argument. So those questions are still an objective good from just a learning perspective. And we couldn't have done all this profiling work without it. But what's interesting here is, let's say you're an interviewer and you wanted to come up with a test of Rust knowledge that didn't take a bunch of time, but gave you a very good signal for whether somebody was going to be a competent Rust programmer. That's the sort of more use case you would have for this kind of data. Now, that said, I should say, like, if you took the set of 5 questions exactly and then asked them, you would probably be somewhat disappointed. Just for example, I have the set of 5 questions in the appendix here. Let me bring them up. So some of them are good, but let me just show you the last question. What is the name of the command line tool for managing the version of Rust on your machine? It's rustup. So you might say, well, that's kind of a weird question to so this is a short answer question. The reason why this is a high core, this I think is included in the basket of questions, is because this is one of the first questions in the book. So what this question in the book is doing is it's filtering out the people who are just not paying any attention from people who are at least paying a little bit of attention, right? But if you ask this question outside of the book context to someone who's like interviewing at your company, this would be sort of a silly question to ask. And so that's one example of just, you do have to be careful leaving the book context and transferring some of these ideas out. But I do actually think the other questions are quite interesting. So you have like a question about drop semantics and ownership. You have a question about mutexes and kind of why mutexes are designed the way they are. You have a question about declarative versus procedural macros. You have a question about expression-oriented programming, so putting braces inside of the F. And then you have a question about like sort of idiomatic Rust. And I think this is actually quite interesting. There's sort of deeper questions about why these 5 questions and not other ones. But I like there's clearly something here.
Do you think someone has already been used these questions in job interviews? Because that's why not?
I don't know. Well, this is my gift to your stream viewers. You're all free. Go to the appendix, grab these questions, or go to the Rust book and grab any of the questions you want. They're all open source. They're just in TOML files that are sitting in my GitHub. So feel free to take any of these questions. Just don't take the low correlation ones. That's the bad idea.
And yeah, thank you very much for these questions. Yeah, so there is a question in chat. How can I ask questions here? So please just write those questions in the chat, and I'll ask them. Unfortunately, we don't have much time left, and I have one more extremely important topic to discuss.
Yes.
And that's your Nota language. Because I am like, well, I was writing LaTeX documents, huge LaTeX documents for like many times, and I always struggle with that. So how can you suggest like fixing this problem with LaTeX? What's your idea behind this project?
Yeah. So there's a lot of ideas behind this project. I think the two big ideas, one is the problem is with PDFs. So like PDFs are kind of an outdated mode of document communication because you can't easily like PDFs are too static essentially. And that staticness is good in some respects, but I think not the future in other respects. Like you can't easily read a PDF on a phone, for example. You can't easily scrape information out of a PDF. You can't embed interactive content into a PDF. There's so many things you can't do in a PDF, but you can do with a richer interface environment. So, and you could see that too. A lot of publishing companies are moving towards e-textbooks, online textbooks, interactive textbooks. But there's no standardized format. They're really annoying to write. And in particular, the most interesting aspects of an electronic textbook, like the interactive bits, are exceedingly difficult for someone to do well. And there's a lot of data that shows this. So I think that's one side is what is the sort of like interactive textbook or document or paper of the future that we want to be able to write? And Noda's goal is to make it possible and easy to write those kinds of documents. And then the other side of this is how do we design a proper document language around a sort of principled system of computation? So the stupid thing about LaTeX is an amazing tool. I hat off to Don Knuth. The man knew what he was doing, and there's a reason why LaTeX has survived as long as it has, because it is an incredible tool, especially at typesetting. But the problem is Don Knuth was not thinking too deeply about the computation system, and so he came up with unhygienic macros in a like unityped language, basically. And so and the reason why this really matters, what actually bothers me, is no one can write a tech library. Obviously someone can, but there's like 5 people on earth who do that, and no one else, right? No one feels empowered to create their own significant LaTeX scripts beyond just like big bags of macros. And I think that if you had a better system of computation integrated into your document language, then it would be like if you had even just the notion of like a list, a number, right? Basic data types and computations and loops and stuff. It would be a lot easier both to describe documents that have interesting computations, but also for people to create their own domain specific components to be able to share things around. So actually, the sort of original reason I got interested in this is I was really frustrated with trying to do interesting forms of communication for my own papers. So I mentioned the like program slicer paper earlier. I decided to rewrite that paper as an HTML file. And I was like, oh, what are all the things I would do differently if I could make it interactive? And one easy thing is like, well, first, it's an algorithm. I would make it an interactive algorithm so you can dynamically generate slices within the paper. That's a no-brainer, right? But also, there's a bunch of math in it, and I want to make that math easy to understand. So now, anytime there's a symbol in the paper, you can say, well, what does this symbol mean? Where is it defined, right? Or if I'm explaining some kind of inference rule, and usually there's like lots of math and lots of text, I can put those next to each other. I can put the text into the math, and then I can say, toggle it back and forth if I want to see the mathy version or if I want to see the prose version. Or if I'm explaining that two things are like related to each other, like I have a prose statement of a principle and a math statement of the principle, then I can explain that correspondence systematically by using colors and interaction to emphasize which pieces of the prose statement correspond to which pieces of math. All basic ideas that are just impossible in LaTeX. But I was like, oh, cool. It would be awesome if I had a paper that could do all this. And so that was really the inspiration for me, is thinking about what kind of technology would you need to support this, right? And the problem is there is no good technology. Markdown will not do this, and any derivation of Markdown is not really enough. Nobody wants to write their papers in React.js. Well, okay, I kind of do, but not in literal JSX syntax. So that's kind of the space I've been exploring. It's still all very early days, but this is the kind of problem.
It doesn't look like very early days, to be honest. It's like a very like amazing thing.
Well, thank you. I mean, I'm hoping to have some kind of like real tool that people can use soon. I mean, Noda, in a sense, is that. It is a real tool that people can use, but it's not. it's not the final iteration. It's getting close, but it's not the final iteration of what I want yet. In particular, because I think there's a lot of interesting questions about this archival bit. Like, if you say, oh, this is going to be our document representation 1,000 years out into the future, I'm more likely to believe that PDFs will be readable in 1,000 years compared to a React.js program. Like literally a .js source program that contains a bunch of React, I think is less likely to be readable than a PDF. And that's a problem. So if my answer is all papers of the future are just sugar on top of React.js programs, that's probably not a good idea. And that, I think, is the sort of sticking point, is finding a design in this big trade-off space that gives you enough expressiveness that it's worth it for transitioning to a new document format, but still has all of these but still, right, so that it keeps all of these important archival stability aspects you expect out of your documents, but also has the benefits of moving to sort of a more flexible medium. I wrote a whole post about that called portable EPUBs that I've been thinking about, like, well, what if you used EPUB as a replacement for PDF? Oh no, I need to fix the service worker, and it never works exactly as I expected. Well, okay, maybe this particular demo may not work in time for today. But yeah, so I service worker internals, unregister. Okay, this is probably too much to try and fix today. But what? Anyways, I can share the link later. But I've just been interested in this question of what is the actual, like, literal format that would replace PDF? Even that question, nobody really has a good answer for yet. And so I think that's kind of the problem I've run into. The farther you go in the space, the more you realize there's this big tower of unanswered questions that you kind of need some good answers to before people would meaningfully use these kinds of tools. Or even just the basic fact that the browser is really bad at typography makes some people like myself very sad. There's just a ton of stuff that you can't. It's actually quite easy to do, and tech is very good at, but you can't, like text justification. This just works really poorly in HTML, and there's no good way around that. So, I mean, at some point, my goal is to say, like, all right, perfection is the enemy of progress. Just like, let's get something out there that people find useful, at least that they could put on like a blog or something like that. That's my initial goal, is people who want to write interactive blogs could use this technology for good. Well, hopefully we'll get there soon.
Well, this brings me actually to my last question. So you are doing so many interesting things. What's the best way for folks to follow what you are up to?
Oh yeah. Oh, thanks for asking.
What should they?
So I have a Twitter at, let's see, twitter.com/ton TONOF crate CRATES, ton of crates. So you can follow me here. I'm also on Mastodon at mastodon.social/ton of crates. So I maintain my social media here and here, and I tend to post about my research. So feel free to follow me in either place. You can also, if you want to talk to me individually, you can send me an email. And on the off chance that you are considering PhD programs, I'm also recruiting PhD students for the next application cycle. So feel free to reach out and talk about that as well. I'm going to be living in Providence, or moving to Providence, in a few months. So if you are in the Providence, Boston area, you can message me and we can also grab coffee. I'm happy to talk about documents, programming languages, education, tools for thought, all this kind of stuff.
Yeah, amazing. So thank you very much for everything you are doing in Rust ecosystem and beyond Rust ecosystem, as we see here. And well, thanks everyone for joining this Rust Rover live stream series. We'll definitely have something interesting later, maybe in a month, maybe a little bit later. So please follow us, follow Rust Rover Twitter account. Everything will be posted there. And so thank you very much, and bye.
Yeah, thanks for listening. Thanks, Vitaly. Bye, everyone.
Bye.